students.
Good afternoon, sir.
So today I'm teaching you in class. So our topic for today is development by triangulation. So by the end of this class, you must be able to identify a different method of development. Secondly, draw the development of various types of translational piece and their applications. Moving on, as in industries, when different pipes or vessels have different shapes and size are to be joined, there are facilitators by using special section called transition piece. The transition piece are the sheet metals objects used for connecting pipes or opening either of different shapes of cross section or the same cross section but not arranged in identical positions. In majority of this case, the transition piece are composed of plane surface and conical shape. The conical shape surface are developed by triangulation techniques. These are highlighted in the subsequent paragraph. The triangulation development is employed to obtain the development of transition piece. This consists of the following. Transition piece is joining a curve across section to a non-curve cross section. Example: square to round, hexagon to round, and lastly square to ellipse. Joining two non-curves across section. Example can be square to hexagon, square to rectangle, square to square in unidentical position. Joining two curves section. Example: circle to oval, circle to an ellipse. In this method, the lateral surface of the transection piece is divided into a number of triangles. By finding the true length of this side of each triangle, the development is drawn by laying each one of the triangles in their true shapes and joining each other. Pipes and ducts are conducting air, gases, powder, solids, etc. often require two dissimilar sections to be smoothly joined, usually by transition piece. A pattern of development has to be made before cutting, folding, and joining the sheet metals to form the transformer piece. You can see this is an example of a transition piece, rectangle to square. Given below is the development of a circle to rectangular transition piece. The pictorial sketch of a circle to rectangular transition piece is shown folding lines. So I have drawn one example on the board. So now what you will do? You take your compass, put it on point 3, and point 3 to point D, make an arc. You will get one point over here. Take this point down, join this line, and join from this point to point 3. And then, now you join from point 3 to the point 2 and 4. Point 2 and 4. This is your X and Y. This is your X and Y. So now what you do? You take the point from 2 to 3, mark over here. You mark, you get this line down. Again you join this one, this point 3 to point 1. Now what you do? You measure from B to D, make an arc from D to B, and from D to B make an arc. That's the point you'll get. Bring it down. Now what we'll do? We'll measure from point 3 to point X and Y. And you mark here and here. Join this one. This is your X and this is your Y. Now again, you'll join from point DB to point 3, from X to point, mark an arc over here, mark an arc over here. Now you join this. Now take the distance from 2 and 3, put it on the point you got over here, mark 2 and 3. This is your 2, this is 3. Join this line. Again, take the same distance from 2 and 1, put it on point 2 and mark. Point 2 and mark. That's 1. Same thing over here. Put it on point 3, mark. Now what you'll do? You join this line. Now you have completed the development triangulation. So in next class we'll be looking further towards the review questions, and we'll work towards the differentiate between triangulation development and a parallel line development, which is shown over here. Example 2. We'll look at this. Thank you.